In this video I show you how to use the GMX mindist tool to calculate the minimum distance between atoms of residues of two protein chains. While GMX distance tool is used mostly to track down the general changes in overall distance between two index groups as a function of time, GMX mindist tool is designed to analyze the minimal distances between atoms of two index groups. The GMX mindist tool command line interface expects you to provide the trajectory file, a file with topological parameters, file with index groups. You must also specify the output files which you want to have. By default, the GMX mindist tool outputs the file with minimal distance between two index groups as a function of time. Optionally, you can get the output file with number of contacts between atoms of two index groups. You can also optionally get the file with minimal distances of atoms of residues in the first index group from the atoms of the second index group. In this case, you will only get meaningful output if your first index group actually contains residues. Otherwise, the file will be empty. Files that I have already mentioned all have XVG extension, so you can plot them. Among non-XVG files, we have a file without extension, which is basically a contact map between atoms of first and second index group. Last but not least, we have a compressed trajectory XTC file. However, it is not a full trajectory file. This file contains only those atoms of two index groups per frames which are considered to be in contact at this particular frame. In general, the GMX mindist tool is more useful in structural analysis than the basic distance tool because it focuses only on the relevant contacts between atoms of your index groups of interest. You can use it to track down the minimum distance between your protein and ligand. You can also use it to determine which protein residues your ligand have contacts with, and also to analyze distances between atoms of your ligand and protein. In this case, however, I analyze two protein chains, which is also often useful. Here we have minimum distance between atoms of two protein chains as a function of time. And in this graph, the minimal distance between residues of protein chain A from the atoms of protein chain B is plotted. Basically, the residues with minimal distance are the closest to the residues of chain B, and therefore they belong to the intedimer interface of our protein complex. Quite useful in analysis of protein complexes with biologically active compounds. This next plot shows us the number of contacts between our two protein chains as a function of time. You can control the actual minimum distance by passing it with D flag to the command line interface of mindist tool, and you can even decide to analyze maximum distance instead of minimum distance with the respective flag. Now that we have plotted all of the XVG files, let's look at the content of all output files. XVG files content is straightforward, so I will just briefly show them. the out file which contains our contact map. The first column is the distance between two atoms. The second column is the index of our atom in the first group, and the third column the index of atom in the second index group. That's all, folks. Let me know if you have any questions.